Okay, so our motivation behind this design was to harness the rotational energy found in wheels, and then further narrowing it down for wheelchair users, harnessing the energy lost by the wheel rotations that they do in their everyday motion. So that was the motivation around designing this. And then once we found a way to harness that energy, we can use it and output it in some useful form in a creative way that someone else can think of. The energy outputted can be used in many different ways. So that wasn't our concern. Our concern was efficiently harnessing the energy so that it can be used for some output that they need.
So as we can see, basically in the demonstration within the prototype, as you spin the wheel, the LEDs light, and that's basically to say that this rotational movement of the wheel is creating some power and some energy. So in terms of the actual calculations and in getting, researching specifically, how much we're actually getting. So we've got 6 coils in one wheel, and kind of spreading that out to a real wheelchair, which would obviously have the one wheel on one side and the other and another wheel on the other side. So we're getting around 6 coils. Each coil alone is producing about 0.01 watts per rotation. So scaling that out to 2 wheels, we're getting around 0.12 watts per rotation. Now again, going further with our analysis and saying, okay, so what can they actually do with this? A rotation itself on average takes around 5 seconds. So they're looking at in a minute, they're generating around 1.44 watts of power, which is quite impressive. And essentially, the unit itself. Now, again, the prototype being what you see here, the real unit would be slightly different in the sense that the solenoids themselves would be installed within the wheel, within the spokes of the wheel. So a lot of this would not be seen. Just for the sake of the prototype, we're able to show what's actually happening here.
All right, so. If you can see the presentation here, this would be the idea we had for the final product. This unit you see here would attach onto the yellow wheel that's on the rim.
Yeah, let me get it.
All right. So again, this unit here would be attached on the yellow rim over here. The wheelchair, the manual wheelchair, again, this will be only outfitted 2 manual wheelchairs. The manual wheelchair would have some sort of control device that would allow the user to determine when to activate and deactivate the assist, and also how much assist to allow that they would want for their wheel. This is for small jobs, like going up hills when the user is really tired. So other parts of the design include a lightweight battery, some sort of lithium-ion kind of battery that would be able to hold enough battery to power the motor. Again, also a lightweight motor. One of the key things in the final design is that the weight distribution of the entire system has to be very even, so that the user doesn't have to worry about the extra force to actually propel them forward. The final concept of this disc here is seen in this yellow disc. The final product would not be made out of wood as it is in our prototype. The final product would be made out of some sort of fiberglass base component, which would make it much more lighter than our prototype. And again, as mentioned earlier, it would have many more solenoids and possibly more coils to probably generate more wattage. Again, the prototype here generates about 0.12 watts per revolution, but it's very feasible that with a refined design, we'd be able to generate 2 watts per revolution. And that's basically it.
So, in summary, I'm just going to wrap up by saying real quick that what we found was the price difference between a manual wheelchair and a fully automated wheelchair is actually quite a big gap between the price. So what we aim to do is create a type of hybrid device that wouldn't have as big of a battery as the fully automated device, but it would also not be fully manual. It'd be in between, in the sense that a little bit of energy put into the system will hopefully benefit them at some other point. So that was our design, and this prototype is demonstrating that.